Hey guys, so welcome to the first video of me configuring this network. Um, like I said in the introductory video posted on LinkedIn and YouTube, we're gonna go from step one all the way to step five, and we're gonna make sure this network is highly redundant using Ether channel, HSRP, DHCP split core, as well as multiple floating static routes. And we're going to make sure at the end that we can ping from the ISP router to each VLAN and that everything looks good via do show runs and do show IP interface brief commands. So let's get started with a network topology of this scope. And since we're using VLANs, I would recommend starting by first configuring every VLAN on every switch. And since we're not using VTP or any other uh, service such as that, we will just go manually one by one, starting with switch 2 and then going to the right. So let's go see right now current configurations. I'll say enable, do show, well, in this mode, we can just say show run. And we can see everything's not set up, and we should first set up the VLANs and we'll go from there. So I'll say enable, oh, that's already done, conf T. And to set up the VLANs, we'll first see what VLANs we need. So the blue is VLAN 10 and the yellow is VLAN 20 with their respective IP networks. So let's take one more look. Perfect. So for VLAN 10, we'll say interface VLAN 10, change state to up. We'll give a description of, let's say, uh, description, we'll say SVI 2 blue. We could just call that number. And that's it. Do right. Now we're also going to configure VLAN 20 on this switch. So we're just going to say interface VLAN 20 to bring the SVI up. And then we're going to give it a brief description, SVI to yellow. Awesome. Do show, actually I can see do show IP interface brief. And we can see at the bottom, the VLANs will be listed. VLAN 10, VLAN 20, they're in up-down state. Whenever I assign the very first access port for VLAN 10 and VLAN 20 respectively, these will go in an up state. So let's go ahead and do that. I know this is fast Ethernet 1 and this is fast Ethernet 2. So we're going to say interface fast Ethernet 1. We'll say switch port mode access, switch port access VLAN 10. If we say do show run, actually let's say do show IP interface brief, we will see that now that we have assigned VLAN 10 an actual access port, it brings it into an up state as shown by the do show IP interface brief command. So that's how you get VLAN all the way up. Interface F0/2, and I'm gonna say the same thing, switch port. Actually, you know what? I'm not gonna type this out. I'm just gonna push up, switch port mode access, switch port access VLAN 10. I'm gonna say do right. And now let's do the same thing for these. So for 3 and 4, instead of configuring them one by one, there's also a command to configure. If we're going to configure these the same, there's a command to do that. Let's say interface range F0/3-4. So that's going to include both 3 and 4. And then we'll say I'll push up arrow, switch port mode access. Instead of VLAN 10, I want VLAN 20. I'm gonna say do show IP interface brief. After any major change, you want to type in something to see what has occurred. So we can see both our VLANs on switch 2 are in an up state. So that's what we want. Next, we want to configure gigabyte Ethernet 0/1 and 0/2 as trunk ports. Any switch to switch connection is going to be a trunk because you're going to have multiple VLAN traffic here, and trunks allow for multiple VLANs to travel from on this kind of interface. So in order to configure that, and since we are configuring these the same exact way, we can do the range command. So we'll say interface range gig internet Ethernet 0/1 to 2, and we'll say switch port mode trunk, and we'll also say switch port trunk allowed VLAN 10 and 20 because we only have two VLANs on this topology. There's no reason to have any other VLAN here. I'm going to say also, I should also switch the native VLAN because by default it's 1, but Cisco Packet Tracer bugs out a little bit when you have multiple switches and you assign multiple trunks between the switches. Um, usually I have issues such as inconsistent native VLAN type, even though they are the same. The fix is reloading each switch, but instead of doing that, I'm just gonna avoid it altogether and not mess with it. If you wanted to see how your trunk looks, you can say do show interfaces trunk, and we can see here are our two trunks leading out of switch 2. They're on gig 0/1 and 2. VLANs allowed on trunk are 10 and 20. A native VLAN is 1. Usually you would want to change this, but in this scenario, we're going to leave it as is. All right. So now that switch 2 is done, let's focus on this interface and this interface. So we'll click on switch 1. We'll go to command line interface, and we'll say, actually, before we configure these, let's make sure VLAN 10 and 20 are on this switch. Interface, we'll say interface VLAN 10. I'm going to give it a description as SVI2 blue, exit. I'm going to say interface VLAN 20, description SVI to VLAN 20. The description is not necessary, but it's helpful for if anyone else has to modify this network later on. The description helps to know where everything goes, especially later on if this network is heavily modified and there's hundreds of more devices on it. This will give the unfortunate network engineer, oh, unfortunate, I don't know, a little bit of a heads up of what's going on. Okay, so VLANs are assembled on this switch. We'll double check at the end. Let's go ahead and configure this interface. Interface gig 0/1. We'll say switch port mode trunk. And let's see by default what the trunk allows. Look at this. 1 through 1000. That's a ton of VLANs it's allowing. We just want to narrow that down to switch port trunk allowed VLAN 10 and 20. Do right. And let's see, do show interfaces trunk. Let's see what it looks like now. Okay, perfect. 10 and 20. And let's see, let's make sure do show IP interface that our VLANs are up and good. They should be up because remember we established these access ports for VLAN 10 and these access ports for VLAN 20. So for now, this switch is good. Let's move on over to switch 0. And again, we will have to create the actual VLANs. Thankfully, there's only two. Interface VLAN 10. Description, I'm going to say SVI to blue. Exit. Interface VLAN 20. Description, SVI to yellow. Do right. I can say the do right for later, but let's just do it now. Interface G0/0. Uh, yeah, interface G0/0. Oh, that's inconsistent. I can't tell what interface this is. Well, I know it's not gig 1. Interface, interface, gig, interface, gig 0/2, perhaps? Let me see. Shut. Okay, it's definitely that one because this went to the actual whole interface shutdown. So what's the easy way to check if you're not using discovery protocol? I'm currently not using one on this network. No shut, so I brought it back up, but I'm not done. I'm going to say switch port mode trunk and switch port trunk cloud VLAN 10 and 20. Perfect. Let's say do show IP interface brief to make sure our okay, so we're not going to worry too much about these right now. Um, we're looking for VLAN 10, VLAN 20, which are up, and we can see that Gigabyte Ethernet 0/1 is up. I wonder what it's configured as. I'm going to say do show run. So looking for gig 0/1. I'm sorry, gig 0/2. Sorry about that. And we can see it's a trunk and it's allowing VLAN 10 and 20. So that is perfect. Oh, here's our descriptions for VLANs. So that's pretty helpful. Description SVI to blue and description SVI to yellow. Nice. So now that that's done, let's configure this ether channel. So an ether channel is helpful. It does a few things. It helps prevent network layer 2 issues such as spanning tree loops and well, not spanning tree loops, but layer 2 switch loops. It helps with bandwidth and it also helps with the redundancy because if any of these interfaces fail, this logical interface would still be up. So imagine if you only had one interface here. If it failed, there's no connection here anymore. Okay, so how do we configure an ether channel? So for this particular ether channel, I made it the fast Ethernet 1 through fast Ethernet 3 on both sides to make it easy. What we are going to do is say interface range fast Ethernet/1 through 3, and I'm going to push question mark, and we are looking for channel group. Let's see, what does channel group do? Ether channel port bundling configuration. So that's the one I want. I'm going to say channel. I'm going to push tab. Okay, it didn't do anything. I'm gonna push question mark again. Channel group number. I'm gonna make this 1. Just a heads up, when you're configuring a ether channel, you're gonna configure one this side and then you're gonna configure this side. The number has to be the same, or it's gonna think these are two separate ether channel. It will not form an ether channel if the numbers are different. So question mark again, we'll type in mode. And I want to configure those multiple different types of ether channels, and those static ether channels, layer 2 ether channels, and layer 3 ether channels. But for purposes of this video, let's go ahead and just configure a passive LAC key ether channel, and this side is going to be passive, the other side is going to be active. Do you right? And before I leave, I have the Ether channel set up. I'm gonna push exit, and I'm gonna say interface. I'm gonna type in P for port, O for channel, and one. Port channel one. That's gonna bring us to the actual logical Ether channel. And I want to configure this Ether channel the same way I would configure a switch to switch link, which is going to be configured as a trunk. Switch port mode trunk. And not only that, I want to also say I only want VLANs 10 and 20 allowed here. So something like that and do right. So this side is good, but I also have to do the exact same thing on this side. So let's see what we have. So interface range F0/1 through 3. I'm going to say channel group 1 mode active. All right. And then I'm also going to say I'm going to say exit interface port channel 1. And I want to configure this as a trunk. Switch port mode trunk. There we go. And I also want to configure it in such a way that it only allows the two VLANs that we currently have in our network topology. Do right? All right. So let me just make sure I've configured everything so far that we need. Do show run. Port channel is good. These are all parts of the port channel. And uh, by the very nature of a switch, all these interfaces that are still unused are actually up. The best practice is typing in fast Ethernet, whatever fast Ethernet port you're not using, all the way to the last fast Ethernet port you're not using, and typing in shut, so they all go into shutdown phase. Um, but it's kind of time consuming to do that with all three of these switches, so I'm gonna not do that right now for the sake of time. I'm just making sure my trunks are set up. The most annoyingest thing is forgetting to do something and then finding the needle in the haystack error that you have made. All right, so it looks like everything's good. Port channel is working. Do show run. Good. Awesome. VLANs are set up. No IP address. I don't really need an IP at the moment since I'm using primarily layer 2 switches and I'm using VLANs that are part of the layer 2 switches. When I get farther into this side of the network, where the layer 3 devices are, I will use IPs a lot more. So all of these interfaces going to the routers, they're all going to be configured the same way. They're all going to be configured as trunks. So let's go ahead and I'm going to configure these really fast. Interface G0/2, switch port mode trunk, switch port allowed VLAN 10 and 20. That one's done. Oh, wait, oh my. Allowed switch port. Oh, I forgot trunk. Sorry, guys. Okay, that one's done. Even though this is red, it's actually in a no shutdown state. Since it's connected to a router interfaces are shut down by default. In order to bring this up, I have to say no shut to this interface here. So we'll do that in a minute. All right, and unfortunately, I couldn't use interface range because you can't use it with like different cables, different cable speeds. So we'll say interface fast Ethernet/4 switch port mode trunk switch port trunk allowed VLAN 10 and 20. Perfect. So I'm sorry, switch 1 is finished. Okay, for switch 0, we are gonna configure interface gig/01 as a switch port trunk, and we're gonna just say I only want these two VLANs on my network. I'm gonna say do right. I'm not sure what connection this is. I think it's fast Ethernet 4. Can't tell. Unfortunately, my shut command won't show me anything here because this is configured to a router. But I'm pretty sure it's right. I'm almost certain on it. Switch port trunk allowed VLAN 1022. Right. Perfect. So everything's configured properly. Um, Now with router on a stick, I am going to configure sub interfaces. And on those sub interfaces, since I have two VLANs, one VLAN will go this way and one VLAN will go this way. So 10 and 20, for example, and then 10 and 20 for this example. So let's go ahead and do that. We'll first learn how to configure a sub interface. I'll say router conf t interface. We're going to focus on the top one first. Gig 0/2. I'm going to say no shut. You'll see it goes in a up listening, learning, but soon to be upstate. From here, we do not need to configure an IP address. Instead, we want to go into interface again, type G0/2 and say .10 because this is an interface that's going to carry VLAN 10 traffic. Before I do anything else, I have to type in encapsulation.1q and we'll make it 10 for VLAN 10. And then we'll give this an IP address um out of the network pool here for VLAN 10. So I want to use my farther back uh IPs. So let's say 250 for this one. 255.255.255.0. Perfect. Do right. And now in theory, now that I have this router ready for VLAN 10, in theory, since all these have the VLAN 10 on them, I could, I should be able to ping that if I wanted to use this as a temporary default gateway. So let's just test that theory real quick. Before I do that, I gotta just double check what that IP was. 250, okay, good. So later on, I'm gonna make this a DHCP IP. So let's say that's my default gateway, and this one's going to be this PC is going to be 192.168.1.1. The subnet mask of /24. Yep, perfect. Can I ping? Let's find out. In theory, traffic should go to here, here, and then here. So ping 192.168.1.250, I think is what I made it. And that is what we want to see. Perfect. Good. Just to be sure that there's two-way connectivity here. Perfect. So we know that we have set up things properly if my packet can travel through all this mess to talk to this PC. All right. So we've configured an interface for VLAN 10 through gig 0/2. Now I'm going to configure a means for VLAN 20 to reach out to VLAN 10, or perhaps, well, I guess only VLAN 10 at the moment because we still have to set this up. So let's go ahead and do that. Interface gig 0/0. Let me just double check, make sure I have the right interface. Okay, good, I do. I'm going to say no shut. And then I'm going to resort to going into sub-interface mode. G00, and we want to work on VLAN 20, which is the yellow. I'm going to say encapsulation dot 1Q 20, and then I'm going to say else IP address. We'll make this one 192.168.1. Sorry, dot 2.250. So it's the same except the octet is a 2 instead of a 1. And there we go. You're right. Now let's test this one as well. I'm going to make PC2 have the default gateway of 192.168.2.250. And I'm doing this because right now it's really relatively easy to figure out what my mistake is if I had made. Later down the road, the more you work on a network, the harder, the more complex it becomes, the harder it is to pinpoint. Right, oops, 250. Awesome. That is what I want to see. So everything's working. Let me just confirm two-way reachability. Do ping 192.168.2.1. Perfect. We are there. All right. So these are set up properly. I just confirmed that through the pings working. So I said do right. Let's do the same thing with this router. All right. So here we will configure enable conf t interface G0/1. I think that's this interface. When I say no shut, if it whatever turns green, that's what I know what interface it is. So yeah, it's that one. We'll say since we made this one for VLAN 10, we'll make this one for VLAN 10. So it's easy. The inside ones are VLAN 20. Okay, I want to configure my sub interface. Interface G0/1.10 encapsulation .1Q 10 IP address. Let's make this one 192.168.1.251. 255. Oh shoot. Perfect. That one's done. All right, then I'm gonna go to this interface here. I'm assuming that is gig 0/0 possibly. No shut. Okay, it's not that. So I'm gonna say shut interface gig 0/2 interface gig 0/2 no shut. There we go. My links are up. It's that one. Interface gig 0/2.20 encapsulation .1Q 20 IP address 192.168.1.2.251 255.255.5.0. Do you right? Perfect. So my configurations are good so far. And now I have it currently that um, this router is the default gateway. This one's not actually being used at all. But when I configure HSRP, that's going to change. And let's go ahead and let's go ahead and do that now. So to configure HSRP, what we will do is say exit interface G0/2.10. We're going to configure HSRP, which is a first hop redundancy protocol, um, onto the actual interface that's carrying the VLAN traffic. So I'm going to push question mark. We're looking for standby. We'll make it standby and see what our options are. Let's first make it version 2. Standby question mark again. Let's make it standby 1. So similar to how Ether channel had the group numbers, the standby has a group number as well. And you can use the group number to separate different VLANs. So like, actually, you know what? I want to make this standby 10, VLAN 10, And when I configure VLAN 20, I'll use standby 20. Standby 10, question mark. We'll make this the priority gateway for VLAN 10. We'll say preempt standby 10 priority. And with HSRP, the higher the number, the more of a priority it has. So I made it, I think it's by default like 100, so it will automatically win. Standby 10 and the IP. Okay, this is where things get a little strange because typically two devices can have the same IP address. You'll get a dupe app error that just constantly goes off. But with HSRP, router 1 and router 2 will share a virtual IP, and that way, if one of these goes down, then there's redundancy because the other one will take its place. So let's go make this a the very last IP of the network to make it easy to remember. What did I do wrong? Oh, huh. Oh, okay, I don't have to add the subnet mask. Sorry, guys. Do right. All right, so I'll priority HSRP router is going to be this, which means I want to do the same thing on this router, but I want to make sure this one's not preempt for VLAN 10 and it's not the priority for VLAN 10. So interface G0/1.10. I'm going to say standby version 2, standby 10, IP 192.168.1.254. Perfect. I don't have to do this next command, but just to make sure it's at 100. Oh, I must have forgot to say which VLAN. Yeah, that should be all that I need to do for that. And if I say do show run, you can actually see the standby phases that it's in. So here we go, standby 10, perfect. Standby version 2. And now, for VLAN 20, we're going to do the complete opposite. So this is the prioritized router via HSRP for VLAN 10. We'll make it the not we'll make it the secondary for VLAN 20. So let's make this one the primary for VLAN. Why am I getting that issue? Wait, this is active. Okay, so this router is active when it should be standby. So what did I configure incorrectly? Oh yeah, this is the error you will get if you configure duplicate IPs. Um, so in this scenario, it's a very annoying issue because it will just keep going. But I'll say shut. There we go. That shuts that down. And I already see my error because when I shut that down, you can see this link is still up. So that leads me to wonder, what did I actually configure? Let me just check. Do show run. But yeah, that's the error you'll get if you accidentally um, set the wrong. That's odd. Yeah, these are right. It's just there's some reason this one decided not to let me see, standby 10 question mark priority 100 and say no shut. This is I configured the wrong interface. because this is the one for VLAN 10, so it's gonna keep giving me that dupe IP error. So let's see. Yeah, there it goes. Because it's not supposed to be. If you have both of them active due to misconfiguration, it will keep doing this. So let me shut that down. Let me figure out which interface this is. That's odd. Or maybe I misconfigured this one. Do let me just say do show IP interface. No, no, do show one. Let's try do show. Okay, so the error is not actually on this router. It's on this one. This is gig um Ethernet 0/2. And let's see. Nothing's hmm, let me just double check. Standby, but this is right. 250. Did I give this one IP address of 250 as well, perhaps? Let's find out. Do show run. And we're looking for 250. Why is this? Let me reload this router. Exit, exit, reload. Yes. So just reloading that router. Sometimes Cisco Packet Tracer um has little bugs. Honestly, um for HSRP, okay, good. We have it as an init state, which is we don't want it active. It shouldn't be active. Okay, so enable conf t. Let's say do show IP interface brief in case I have to bring anything back up. That's weird. This shouldn't be active. Exit. I'm gonna say conf t interface. Let me just do this. G0/1 and 10. And I'm gonna say no standby. No we shall run. Okay. So I disabled all my standby configurations. And now I'm gonna say no shut. So it's up. And now I'm also going to restart my standby configuration. Standby 10, priority. I'm gonna leave the priority alone. Maybe that was my issue. IP 192.168.1.254. Okay, good. It shouldn't go to active. I don't know why it went to active the initial time. So it's going through the initial state right now, and it shouldn't change because I have this one as a priority 120. Okay. It looks like it's going to behave this time. I don't know what happened. Just one of the bugs of Cisco Packet Tracer. Why is it going active again? Okay, let me do something real quick. Option, preference, toy shirt. No. So what we're gonna do, let me just double check. Is this 0/1? It is. And this is 0/2. So let me see where my error, maybe my HSRP is configured incorrectly. I want to see for sure what's going on. Do you show run? So 0/2 should be my VLAN 10. Here it is. 192.168.250. Standby version 2, standby IP address, priority, and it's preamps. Okay, that looks right. Gig 0/1. Do show run. Just make sure I'm not missing anything. Oh, these are fine. Okay, you know what? I'm gonna make the um standby 10 priority. How low can I make this? 0. Can I make it 0? Oh, shit. You're right. And that should make it so I'm getting that duplicate IP error because both my HSRP configurations are active. When one's supposed to be initial, for this case, router 2 is supposed to be an initial heating stage, basically, and this one's supposed to be active, but it won't stop doing that. I don't know why it's doing that. Uh, Let me just reload this router. Okay, let's say no shut. It should go. I don't know why it keeps overpowering the one router. And just double check and make sure it's going inactive again. This one's active too. We'll get the error again. Wait, yeah, we want to get it. I'm surprised it hasn't started yet. But I think it's a bug, honestly, because these are set up properly. All right. So since it's acting normal now, we are going to configure gig 00. So let's say do enable conf t who show run. Okay. And we're looking for belong to 20. Which one is belong 20? Good 00 is gonna be 20. So we want this one to be interface G0/0.20. Since this one's supposed to be the priority HSRP router of VLAN 10, this one is going to be the backup router HSRP for VLAN 20. So what we can say is standby 20 IP 192.168.2.254. Kind of scared to do this, to be honest. After what we just went through, standby priority priority 0. Do right. Sorry guys, that should only have taken a few seconds, like minutes. All right. Oh, cool. This actually changed the standby. I don't know what caused that, but Cisco Packet Tracer has its weird bugs. I know I never use BTP anymore because one time I had a network set up perfectly and it would not ping for whatever reason, I can't remember, but it was BTP not syncing with other switches and it's annoying. So I don't use it anymore. So gig 0/2 interface gig 0/2.20. And I'm gonna say standby 20, priority 120, standby 20, preempt, standby 20, IP 192.168.2.254, and then say do, oh, here we go. Okay, good. That one's acting normal. So this is supposed to be the active router. I'm afraid this one's going to try to go active for that. And it looks like it's going to do that. Okay, no, it went back to standby, thank God. Okay. So that's basically getting HSRP set up. It's not that hard. It's just Cisco Packet Tracer acts crazy sometimes. Not only that, I also want to configure DHCP split core, but I think I'm gonna do that on the next video. And I also want to configure spanning tree protocol to work with the configurations that we had just made. Let's assemble these links real quick, and then we'll do everything else in the next video. Interface. This is gonna be S031. Interface serial 031. No shut. I'm gonna also say it's down because the ISP router is down. I'll say IP address 10.10.10.1 255.255.255.252. Do right. Let's set up the other side. Oh wait, that's a serial link, so we also want to get the clock rate. Let's turn them out. We'll make it just for the sake of this lab 72,000. Do right. That's basically the speed of the serial connection. So SE031 enable conf T S oh interface S sorry, serial 031. Let's make sure I'm turning on the right one. No, shut down. There we go. IP address 10.10.10.2 255.255.255.2. Do right. So, yeah, this is gonna be a two-part video, guys, because this is already 50 minutes in. I'm just gonna assemble this one real quick, and let's begin on this one. Interface serial 0/3/ what is this one? 0 to 0. 0. No shut. IP address. This is going to be its own separate network too. 10.20.1 255.255.255.2. Do right. I love you. Oh, you good dog. So my dog's over here. Interface serial 0/3/0. Let's just make sure I get this up. No shut. Interface. Oh wait, sorry. IP address. Whoops. Got this. This located. IP address 10.10.20.2 255.255.255.2. Perfect. So that's the end of this video, and I will finish configuring this lab and the next one. Thank you guys for watching.